Is time really constant? Or is that just how it appears to us? Every moment of your life feels steady. Seconds pass one after another, perfectly evenly. Nothing seems unusual. But what if that feeling is misleading? We trust time because it feels reliable. Clocks tick forward. Days turn into nights. Everything seems predictable. But deep down, physics tells a different story. A story where time is not as simple as we think. What if time isn't fixed? What if it can stretch, slow down, or even nearly stop, depending on how fast you move or how strong gravity is around you? Over 100 years ago, Albert Einstein introduced an idea that completely changed science. Not just a small correction, but a total rewrite of reality itself. Before Einstein, the universe felt simple. Objects moved in predictable ways. Forces acted on them, and everything followed rules that made sense in everyday life. According to Isaac Newton, gravity was a force, an invisible pull between objects. An apple falls because Earth pulls it. The moon orbits Earth because of gravity. Everything seemed to fit perfectly into this explanation. For hundreds of years, this model worked incredibly well. It predicted motion, explained planets, and shaped science. But then scientists studied something unusual: light. And suddenly, the old rules began to break. If you throw a ball while running, its speed changes depending on your motion. But light doesn't behave this way. No matter how fast you move, light always travels at the same speed, exactly the same, for everyone, everywhere. This creates a problem, because if speed doesn't change, then something else must adjust. Einstein realized the answer. Time itself must change. Not objects, not light. Time. The faster you move, the slower time passes for you. This is called time dilation, and it's one of the strangest truths in physics. Imagine traveling in a spaceship close to the speed of light. While you experience a few years, decades could pass on Earth. When you return, you would be younger than everyone you left behind. You've moved into the future. And this isn't just theory. We've measured it using highly accurate clocks on fast-moving planes and satellites. But time isn't the only thing that changes. Space itself also transforms when you move at extreme speeds. Objects moving very fast actually shrink in the direction of motion. This is called length contraction. To an outside observer, a fast-moving object looks compressed, shorter than it really is, and from the traveler's perspective, everything else appears distorted instead. Reality depends on who is observing. This leads to a powerful conclusion. There is no single absolute reality. Everything depends on motion. Out of these ideas came a famous equation, E equals mc squared. This equation tells us something profound. Mass and energy are the same thing. Even a tiny amount of mass contains an enormous amount of energy, far more than we would expect. This is why nuclear reactions release such powerful energy. A small loss of mass turns into a huge energy output. It's also how the sun shines. Inside the sun, mass is constantly converting into energy. That energy travels across space and reaches Earth, making life possible. But Einstein didn't stop there. He asked an even deeper question. What is gravity really? What if gravity isn't a force at all? What if something else is happening? Einstein proposed that massive objects bend the fabric of reality itself, what we call spacetime. Imagine spacetime like a stretched sheet. Place a heavy object on it, and it bends. Now place a smaller object nearby. It moves toward the heavier one, not because it's pulled, but because the surface is curved. That's how planets orbit stars. They are simply following curved space-time paths. Even light follows these curves. It bends around massive objects, showing that gravity affects everything. When gravity becomes extreme, a black hole forms. Here, space-time is so distorted that time slows dramatically, almost to a stop.